In this lesson, you will learn about the Intrusion Prevention System, or IPS. After completing this lesson, you will have the skills and knowledge required to deploy IPS protection in an enterprise network. Tune an IPS solution. Accelerate IPS inspection using hardware offloading, and troubleshoot IPS problems. In this section, you will learn how to deploy and tune an IPS inspection in an enterprise network. IPS uses signature databases to detect known attacks. You can also use IPS signatures to detect network errors and anomalies. Like the antivirus signature databases, the IPS signature databases are also updated through FortiGuard. There is no single correct way to deploy an IPS solution. It depends greatly on the network and application requirements. However, in most cases, you will follow the steps shown on this slide. There are usually 3 stages in the deployment of an IPS solution. 1. Analysis. The administrator defines what to protect and where. 2. Evaluation. After an initial IPS configuration, the administrator makes further adjustments based on the IPS logs. During this stage, you configure the IPS only to monitor traffic, not block it. And 3. Maintenance. After the IPS configuration is working correctly, the administrator sets IPS to protect. The administrator must continue to monitor the logs and make further adjustments if any false positives or negatives occur. You will learn more about each stage in this lesson. During the analysis stage, you must identify what services to protect, the threats to those services, and where to enable IPS inspection. Set realistic expectations. Focus on protecting the services that need protection. Start with the most critical services and classify the threats into groups. During the evaluation stage, enable just one group of signatures at a time, starting with the most critical ones. Wait and analyze the logs. If the logs indicate any problems, fine-tune the IPS configuration. After you feel comfortable with one signature group, enable IPS protection for the next group. This process can take from 1 to 2 weeks. To minimize the number of false positives, make the list of signatures that you set to block small and precise. The list should include the attacks that are the most dangerous to critical services. After you deploy the IPS solution, you must continue to monitor IPS events. When you check IPS events, start with the events that have been generated the most or have high priority. For each event type, analyze the IP addresses, services, and type of attack. The analysis should help you to identify whether the event is a genuine attack or a false positive. Eliminate as many false positives as possible. For each false positive, try to fix the problem by making changes to either the source or destination of the traffic first. You can also use IPS exceptions. In this section, you will learn about advanced IPS configuration settings. The global IPS configuration settings affect the IPS engine operations for the whole unit. Most of the time, you don't need to modify these values because the default ones work well in most scenarios. However, under certain circumstances, changes to these settings may be beneficial. The algorithm setting tells the IPS engine how to do signature matching. There are 4 methods. 1. Engine PEC. IPS Engine chooses the algorithm based on available memory and the type of inspection being performed. This is the recommended option. 2. Low. Slower matching algorithm using less memory. 3. High. Faster matching algorithm using more memory. Recommended when IPS and application control performance are the only focus of the FortiGate deployment. And 4. Super. Fastest matching algorithm, designed for units with more than 4 GB of memory. The engine count setting controls the number of IPS engine processes running on FortiGate. When it is set to the default, 0, FortiGate determines the optimal number based on system load. More IPS processes may result in better performance, but could risk overloading the system. Conversely, reducing the number of IPS engine processes alleviates system resources, but reduces IPS performance. You should tune this parameter if IPS is the only purpose for deploying FortiGate, and only after you thoroughly test the setting change in a lab environment. The Intelligent Mode command controls the adaptive scanning behavior of IPS. When you enable adaptive scanning, IPS determines when it is secure enough to stop scanning the traffic in each session. When disabled, IPS scans every byte in every session. In this section, you will learn how to create custom signatures on FortiManager. There are two categories of Fortinet IPS signatures. 1. Predefined signatures are developed by FortiGuard analysts, which are distributed as part of regular FortiGuard update packages. And 2. Custom signatures are created by users for specialized applications. A custom signature is made up of a type header and a series of option and value pairs. All custom signatures require a header of F-SBID. An option starts with -- followed by the option name, and sometimes a value. Some options don't require a value. You must enclose the string of option and value pairs in a parenthesis. All fields are case insensitive. You can include multiple options in the rule by separating them with a semicolon. The maximum length is 1024 bytes for custom signatures and 4096 bytes for predefined signatures. Now you'll learn about supported option types. The options are divided into 4 categories based on their purpose. Basic options are not related to packet inspection. You use basic options to identify and control a signature. These options will not be covered in this course. Use protocol-related options to match protocol headers. Use payload-related options to match portions of the packet payload. Use special options for various purposes for more granular filtering. If you are planning to create a custom signature, gather as many samples of the traffic as possible. Good samples help you to identify patterns, for example, source ports, destination ports, specific string patterns in the packet payload, and so on. Try to match payload patterns in addition to protocol patterns, because payload patterns tend to be unique to the specific traffic that you want to match. In this way, you might be able to reduce the number of false positives for the custom signature. By default, the custom signature settings are hidden in FortiManager. After you enable them, a new tab appears in the GUI under Security Profiles, IPS Custom Signature. Copy the custom signature and in the window named Create New Custom Signature, paste it into the signature field. In the name field, enter a name. After you add the signature to the FortiManager database, you can apply the signature to an IPS sensor. In this section, you will learn about hardware acceleration options for IPS inspection. The strength of an ASIC chip is in its specialization. Therefore, Fortinet develops several key ASICs identified by their type, network processor or content processor, and their version. Fortinet also develops security processors, which are not considered FortiASICs. The convention name is made up of the family abbreviation plus the revision number. Generally, newer versions have more features and better performance. The graphic on this slide shows the difference in performance between an older FortiGate that uses CPU-only gear and a newer, faster FortiGate with hardware acceleration. ASICs are wired into the circuit board, and therefore you cannot upgrade them. The content processor, or CP, is a co-processor for the CPU. It accelerates many common resource-intensive and security-related processes. Since the very first FortiGate model, Fortinet has included a content processor in the design. The CP works at the system level. CP8 and CP9 provide a fast path for traffic inspected by IPS, including sessions with flow-based inspection. CP processors also accelerate intensive proxy-based tasks, such as encryption and decryption and antivirus. Network processors provide the following features: pre-IPS anomaly filtering and logging, packet offloading, link aggregation, HA traffic offloading, and IPsec encryption and decryption. Security processors, or SPs, provide an integrated, high-performance, fast-path multi-layer solution for both IPS and firewall functions. The IPS starts at a hardware-accelerated engine, which ensures that each packet is without anomalies. Then, DDoS protection, policy-based intrusion protection, and firewall fastpath are employed to prevent attacks. SPs can also offload packet transmission, multicast, IP version 4, IP version 6, and NAT64 traffic. It accelerates IPsec encryption and decryption, performs flow-based content inspection, and provides SYN proxy functionalities. System on a chip, or SoC, combines a general-purpose CPU, NPs, and CPs into a single chip. It accelerates IPS-inspected traffic. SoC is found in desktop and small office models. In this section, you will learn about IPS troubleshooting. There are two important types of daemons that handle IPS-related tasks. IPS Engine is the main type of daemon that handles all inspection and detection tasks, and IPS Helper handles actions whose results can be shared by different IPS Engine daemons. In some FortiGate models, it is normal to see multiple instances of the IPS Engine daemon running. IPS goes into fail open mode when there is not enough available memory in the IPS socket buffer for new packets. What happens during that state depends on the IPS configuration. If the fail open setting is enabled, some new packets, depending on the system load, might pass through without being inspected. If it is disabled, new packets might be dropped. The IPS failopen event generates a log in the crash log. The log indicates if new packets are dropped or passed through. IPS fail open entry and exit events also generate event logs. Frequent IPS fail open events usually indicate that the IPS is not able to keep up with the traffic demands. So try to identify patterns. Has the traffic volume increased recently? Have throughput demands increased? Tune and optimize your IPS configuration. Create IPS profiles specific for the type of traffic being inspected, and disable IPS profiles on policies that don't need them. As a last resource, you can try to increase the IPS buffer size. You should do this type of tuning only after thoroughly testing the new values in a lab environment. The command diagnose, test, application, IPS monitor includes many options that are useful for troubleshooting purposes. The slide shows two of those options. Option 3 displays the log entries generated every time an IPS engine process stopped. There are various reasons why these logs are generated. 1. Manual. Because of the configuration, IPS no longer needs to run. That is, all IPS-related features have been disabled. 2. CFG INIT. There was a problem communicating with the management database, CMDB. 3. Memory cap. The amount of memory used by the IPS process has exceeded the model-specific predefined value. And 4. SEG fault. This is a IPS engine crash, and it usually indicates a bug. You can clear the IPS engine exit logs using option 4. Short spikes in the CPU usage by IPS processes could be caused by firewall policy or profile changes. These spikes are usually normal. Spikes might happen when FortiGate has hundreds of policies and profiles, or many virtual domains. Continuous high CPU usage by the IPS engines is not normal, and it should be investigated. If there are high CPU use problems caused by IPS, you can use the command diagnose, test, application, IPS monitor with option 5 to isolate where the problem might be. Option 5 enables IPS bypass mode. In this mode, the IPS is still running, but it is not inspecting traffic. If the CPU use decreases after that, it usually indicates that the volume of traffic being inspected is too high for that particular FortiGate model. If the CPU use remains high after enabling IPS bypass mode, it usually indicates a problem in the IPS engine that you must report to Fortinet support. If you enable IPS bypass mode, remember to disable it after you finish troubleshooting using option 5. Another recommendation to keep in mind: if you need to restart IPS, do not use the command diagnose sys top kill. Instead, use option 99 as shown on this slide. This guarantees that all the IPS-related processes will restart properly. If the IPS is generating false positives, first determine which signature is generating them. You can use IP exemptions as a solution. Additionally, you can provide sniffer samples and the matching logs to the Fortinet IPS team for further investigation. False negatives are more difficult to discover and troubleshoot. Check the following. 1. Is traffic hitting the correct policy or IPS profile? Use sniffer and debug flow if necessary. 2. CPU and memory use is normal. 3. IPS engines are not crashing. And 4. IPS configuration is correct. Again, after you verify all of those factors, you can collect sniffer samples and, along with details of the application traffic, provide all the information to the Fortinet IPS team for investigation. In this lesson, you learned about the following: tuning IPS configuration, advanced IPS configuration, custom signatures, accelerating IPS inspection, and IPS troubleshooting.